Welcome to The Explainer. Today we're talking about LangChain, which is this incredible toolkit that lets you build with AI like you're playing with Legos. Seriously, you can snap together all these different components to create some really powerful applications, from super smart chatbots to complex data pipelines. So, large language models, LLMs, are just amazing, right? They can write poetry, summarize a dense report, you name it. But here's the catch. Their output is usually just a big wall of unstructured text. And while that's great for us humans to read, it's a bit of a nightmare for other software to work with. And that's really the heart of the problem we're trying to solve. How do you take that messy, sometimes unpredictable text and turn it into something clean and reliable? Something like a structured JSON format that your other applications can instantly understand and act on without any confusion? So this brings us to the central puzzle, doesn't it? How do we build logical, repeatable workflows that let us use all the incredible power of an LLM, but also give us control over what it spits out? The best way to think about LangChain is as this awesome set of AI Legos. And just like with Legos, there are a few fundamental blocks you're going to use almost every single time. You've got the model, that's the AI brain itself. Then you have the prompt, which is basically the set of instructions you give it. And then there's the output parser, which, it's the absolutely crucial translator. Okay, so let's dig in a little deeper, and we're actually going to start with those output parsers. Why? Because they are the key to making an LLM's response actually usable in a real application. And what's cool is you can see how you get more and more control. A string output parser, super simple. It just gives you back text. A JSON output parser is a step up. It asks the model for JSON. But the real game changer is something like the Pydantic output parser. It doesn't just check if you got the right fields, it actually validates the data types. It makes sure that a field like age is a real number, not the word 30, It's all about guaranteeing in the structure of your data. Okay, so now we have our Lego blocks, but how do we actually snap them together? Well, in the modern world of LangChain, we use this really elegant concept called runnables. And the magic connector is the pipe operator. Yep, just that single vertical line. It's so cool because it visually and functionally chains our components together. It just takes the output from the thing on the left and pipes it directly into the input of the thing on the right. It's super intuitive. So at its core, a basic chain, which LangChain calls a runnable sequence, is just a straight line. Your instructions in the prompt get piped to the model's raw text response then gets piped to your parser, and boom, the parser cleans it all up into that perfect structured JSON you wanted. But let's be real. Most useful applications are rarely just a simple straight line. What happens when you need to take different paths depending on the situation, or you need to do a couple of things at once? This is where LangChain's more advanced building blocks really start to shine. Runnable parallel is your go-to for handling complexity. It basically lets you split the path. You can run multiple, totally separate chains at the exact same time, and then it cleverly combines all their results into a single, organized dictionary for you. And then you have runnable branch, which is just brilliant. It gives you if-then-else logic for your AI. So based on the output of one step, like say analyzing if a customer review is positive or negative, you can dynamically decide which chain to run next. A happy review could trigger up thank you chain, while a negative one could automatically fire off an alert to your support team. So smart. And there are even more specialized tools. Runnable pass-through is super handy for making sure your original input data doesn't get lost halfway through a complex chain. And Runnable Lambda, that's like your ultimate superpower. It lets you wrap up any custom Python code you write and turn it into a standard LangChain block that you can just pop into any chain. So let's see how all these blocks can come together to build a real-world application. We can combine them to create something incredibly powerful, like one of those retrieval augmented generation, or RAG systems, that powers so many of the advanced chatbots you see today. Now, a really key piece of any RAG system is something called a vector store. The easiest way to think about it is as a database, but instead of storing text, it stores the meaning of your documents as a bunch of numbers. This lets an AI search for concepts and ideas, not just simple keywords. And check this out. This entire RAG workflow, it's just another LangChain chain. A user asks a question, and we can use a runnable parallel block to do two things at once. Go search the vector store for relevant documents, and also pass along the user's original question. All of that gets bundled up into a new, much richer prompt that we then pipe to the LLM to generate a really well-informed answer. See? It's all just our Legos, snapped together in a clever way. So, if there's one thing to take away, it's this. LangChain isn't just a simple library of tools. It's a whole framework, a new way of thinking about how to compose logic, how to connect language models to your own private data, and how to build really robust and reliable AI applications from standardized, reusable parts. By giving you these powerful and interchangeable building blocks, LangChain really empowers you to move beyond just writing simple prompts and to start architecting truly sophisticated AI systems. So, the only question left is, what will you build with them?